Hi guys, I am Muchekwa and I am back with Maths XYZ, and today we will be looking at trigonometric ratios. So let's look at triangle PQR, which is also a right angled triangle, of which it has an angle of theta there, and the opposite of angle theta is this side. This is the opposite, and the hypotenuse of this angle is this side, and the adjacent of angle theta is this side here. This is the adjacent. From angle theta, we can now remember according to the theorem of Pythagoras, this is normally hypotenuse is normally denoted by the symbol of R, and the opposite by the symbol of Y, and the adjacent by the symbol of X. Then let's look at trigonometric ratio, which is sine, which is cos, which is tan. Of which the first one, sine x, cos theta, I mean to say, and tan of theta. Sine of theta is equals to opposite over hypotenuse, of which this is the opposite over the hypotenuse. And the cos of theta is equals to adjacent over the hypotenuse. And the tan of theta is equals to opposite over the adjacent. But then guys, there's another way that you can actually remember this in an easy way. Just remember a statement which says, oh hell, another hour of algebra, of which oh hell it's for sine, and another hour is for cos, and of algebra it's for tan. Look how it works. Then here it will be oh hell, okay, and this is another hour of algebra. If you can just remember the statement, you will know that oh hell, it's, remember, opposites start with O, and O also start with O, and hypotenuse start with H, and hell also start with H. That means that you can actually just remember the statement oh hell, another hour of algebra, and put them in this way so that you can always remember that sine theta is equals to opposite over hypotenuse, adjacent over hypotenuse is also you can also remember it by saying another hour of algebra, which is for tan. Then in this way it becomes easy for you to remember. Then from here, remember that I said that hypotenuse is also denoted by the symbol of R, and the opposite by Y, and the adjacent by X. That means that for sine theta, it can also be written as Y over R, and for cos theta, it can also be written by saying x over r, and for tan theta, it can also be y over x, according to the theorem of Pythagoras. Then remember that this thing, the trig ratios, only applies if the triangle is a right angle triangle. Like you can see that this side is 90 degrees, and the 90 degrees, it's 90 degrees for angle P. Alright guys, let's just look at some examples, and we can see how we can solve trig ratio questions using what I've already told you here. Alright, remember sine theta opposite over hypotenuse, which is oh hell, another hour of algebra. Then we'll solve the question using this thing. Alright, I will erase this so that I can make space. I'll also take this out. Alright. The question says if tan theta is equals to 4 over 3, then we must give answer for number 1, which is sine theta over cos theta, and number 2, which is cos theta multiplied by tan theta. Alright, then we have our question. It says if tan theta is equals to 4 over 3, then what is the value of sine x divided by cos x, and what is the value of cos x multiplied by tan theta, I mean to say. Then from here we can just draw a triangle, a right angle triangle, and we can still name it angle triangle PQR. And from here we know that if our angle theta is there, then that means, remember, our tan theta is equals to our opposite over hypotenuse, opposite over adjacent, I mean to say, adjacent. our tan theta is equals to opposite over adjacent. Then the opposite of angle theta there is this side, of which this side is equals to 4. And the adjacent of this of angle theta is this side, which is equals to 3. But then remember that we still need to find the side of QR, the side QR, of which we know according to the theorem of Pythagoras, r squared is equals to x squared plus y squared. Then from here we can have x squared, of which we know is 3 squared, plus our y, which is equals to 4 squared is equals to, this is 9 plus 16, 9 plus 16 years, of which it will be equals to 25, and we know which is equals to 25. But then this side is r squared, of which to find the value of r, it will be root 25, which is equals to 5, plus or minus 5. Then from here we know that the side is equals to 5. Then we can now solve for sine theta divided by cos theta, of which we know that sine theta is equals to opposite over hypotenuse, which is opposite over the hypotenuse 4 over 5. And then cos theta is equals to adjacent over the hypotenuse, which is 3 over 5. Then let's solve the first one and see what we're gonna get, which is sine theta over cos theta. It will be opposite, which is 4 over 5, and then divide by also cos theta, which is adjacent over the hypotenuse, which is 3 over 5. Then from here we know that it will be 4 over 5 multiplied by 5 over 4, it will be 4 over 5 multiplied by 5 over 3, of which this will cancel out and we'll be left with 4 over 3. We will be left with 4 over 3. And then, okay, another thing, if you can already see it, that our answer is equals to 4 over 3, which is equals to the answer for tan theta. Remember that sine theta divided by cos theta, it actually gives us tan theta, which is why if we would have even from start just say that sine theta divided by cos theta, it actually gives us tan theta, and we would have just given an answer straight away that it's 4 over 3. But just wanted to show you that it does prove even for this question that sine theta divided by cos theta, it is indeed equals to tan theta. And then let's do the second question, which is cos theta multiplied by tan theta, and see how what our answer will be. Number 2, which is equals to cos theta multiplied by tan theta. We know that our cos theta is equals to adjacent over hypotenuse, which will be 3 over 5. And then our tan theta, we already have it, which is 4 over 3. 4 over 3. And this 2 can cancel out the 3, and the 3 will cancel out, and we'll be left with 4 over 5. Alright? Okay. Remember, when you are solving this question, tan theta is equals to 4 over 3. Just remember that means that your 4 is your opposite and the adjacent is equals to 3. And then from there, you just draw a triangle so that you can see which side is missing. And then from there, you calculate the missing side, of which for this case, it was the hypotenuse, which is also r. And we use the theorem of Pythagoras, r squared is equals to x squared plus y squared to get r squared, of which for this question we got 5. And then from there you can solve the question that you are given to solve. Like you know that your sine theta is equals to opposite over hypotenuse, and then your cos theta is equals to adjacent over hypotenuse. It will always help that before you can answer any question in trig ratios, you just write them down, that your sine is equals to this, your cos is equals to this according to trig ratios. And also if you can use that statement that I told you about, that here another hour of algebra, then it becomes easy for you. Just when you're answering question, you just go back to what you have already written, your notes in a way, and then you can solve it from there. And remember, always draw a triangle so that you can see which side is missing, and it becomes easy for you that you can always see which side is opposite, which side is adjacent, and which side is hypotenuse. Alright, let's do another example, and we'll see how we can still apply the trig ratio in this question, in the question. Alright. This example, it says if 3 sine theta is equals to 2, then we must give for the first one, determine the value of tan theta. And number 2, it says determine the value of sine theta divided by cos theta. And number 3, it says determine the value of sine squared theta plus cos squared theta. Alright, I told you guys that the first thing that you must draw is the triangle so that you can see which side is missing. Then let's look at our question, which says if 3 sine theta is equals to 2, then we must determine the value of the following, which is number 1, number 2, and number 3. Then taking 3 sine theta in here is equals to 2. What we must do now is to divide both sides by 3. Then after that, we'll have sine theta is equals to 2 over 3. And then from here, we know that our sine is equals to opposite over hypotenuse. Then from there, we can now draw our triangle, of which our angle is there. This is sine theta, and we can always name it PQR. And then from here, our sine theta is equals to opposite over hypotenuse, of which 2 is our opposite, and then our 3 is the hypotenuse. That means that the missing side is equal, it's x, which is the adjacent. Then using the theorem of Pythagoras, r squared is equals to x squared plus y squared. That means that to get x squared, it will be r squared minus y squared. And then from there, we can actually have x is equals to square root of r squared minus y squared. And then from here, we know that our r, which is the hypotenuse, is equals to 3, of which it will be 3 squared minus our y, which is the opposite, is equals to 2. Then it will be 2 squared. That will be 9 minus 4, which is 5, and we don't really have a whole number of a square root of 5. Then our answer is equals to square root of 5. That means that our x there is square root of 5. Then from there, we can now solve for tan theta, sine over cos theta, sine squared theta plus cos squared theta. Of which the first one, by just looking, number 1, which is tan theta, we know that tan theta is equals to adjacent over, tan theta we know that is equals to opposite over adjacent, of which our opposite is equals to 2 and our adjacent is root 5. That means that the answer for the first question is 2 divided by root 5. And then the second one, which is sine theta divided by cos theta. Remember, I told you that sine theta divided by cos theta is equals to tan theta. That means that the first and the second question, it has the same answer. But then, just for satisfaction, you can solve it by just looking at sine theta, which is equals to 2 over 3, it's opposite over the hypotenuse, divided by cos theta, which is root 5 over 3. The 3 will multiply out, and you will be left with root 2 over, you'll be left with 2 over root 5, which is also equals to tan theta.